We are on 2.5, part 2. So we're going to start off with reviewing what we did the day before, which was solving compound inequalities. If you remember, we had and or inequalities, and how that affected the solution was based on where you are shading on the number line, or in other words, where the solution is. So we're going to start off with our first one, and right off the bat I can tell it's an and inequality just because of the format. If you remember, our first step is to isolate the variable, which in this case is x. So I'm going to subtract 1 from all parts of the equation, and I get -3 is less than 3x, which is less than or equal to 9. And again, I'm still working on isolating that x. So right now it's being multiplied by 3. So we're going to go ahead and divide by 3 from each part. So -3 divided by 3 is -1. And I would get is less than. So keep in mind, all I'm doing is bringing down the signs. The 3's cancel. So I get x, and then bring down the sign, is less than or equal to 3. So what this means is the solution is between -1 and 3. It does not include -1, but it does include 3. So I'm going to go ahead and graph this on a number line. I'm going to make it kind of sloppy, so I'll say that's -1, 0, 1, 2, and 3. So at -1, I should have an open circle because it's just greater than -1. And at 3, I should have a closed circle because it's equal to. And then I'm just going to shade everything in between, because what this is saying is it's greater than -1, but less than or equal to 3. So if I asked you for a solution, you could say 0 is a solution, 3 is a solution, -0.5 is a solution, but -1 is not a solution, 4 is not a solution. It will not make the inequality true. All right, this one we have an or inequality. It's kind of a giveaway because it says the word or. So what we're going to do is treat these separately and solve for x for both of them. So for this one, I'm going to go ahead and subtract 2 from both sides. So I get x over 5. Those 2's cancel. I bring down my sign, and I get -4. And then from there, I'm going to go ahead and multiply by, +5. And so we would get x is less than or equal to -20. And on this next one, I'm going to start off by subtracting 1. So I get 8x is greater than or equal to 40. And then I divide by 8. And I get x is greater than or equal to 5. So I have x is less than or equal to -20, or it's greater than or equal to 5. So when I'm drawing this out, these numbers are kind of big, or I should say kind of small. So I'm just going to say this is -20, and we'll go by 5s. This would be -15, -10, -5, 0, and 5. So at -20, I want a closed circle, and at 5, I also want a closed circle. At -20, we know that it's less than or equal to -20. So I'm going to go ahead and shade everything smaller than -20. And at 5, we know it's greater than or equal to 5, so everything bigger than 5. Okay, so these next two are your turn problems, so go ahead and pause the video and do them. Okay, so for this first one, what we're going to do is, again, get this x by itself in the middle. So we're going to add 1 to all parts. And I would get -5 is less than or equal to 5x. Those 1's cancel. And I get 10. The next step would be to divide each part by 5. So negative 5 divided by 5 is negative 1. I bring down my sign. The 5's cancel, and I get x. And 10 divided by 5 is 2. So the solution is between negative 1 and 2. So I have negative 1, 0, 1, 2. At negative 1, I do a closed circle. At 2, I also do a closed circle. And since it's greater than negative 1 but less than 2, I shade everything in between. This next one, we are going to treat it like two separate inequalities. So I'm trying to isolate those x's. So for this one, I'm going to add 1 to both sides. So I get x over 2 is greater than 3. And then from here, I'm going to multiply both sides by 2. So that will cancel out our 2. So we get x is greater than 6. Now I solve this problem. So I'm going to subtract 3. So I get 4x is less than negative 16. And then I'm going to divide by 4. So I get x is less than negative 4. So we have that x is less than negative 4, but it's greater than 6. So if this is my 0, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, 6. So at negative 4, I have an open circle, and at 6, I have an open circle. It's less than negative 4, so it's going away, and it's more than 6, so it's going away. And again, I would just put my or in the answer. So the new topic for today is exactly the opposite of what we just did. So what you're going to be given is the graph, and then you have to work backwards to find the inequality. So the first step is deciding, is it an and or an or inequality? So this one is an or because they are going away from each other. So I'm going to go ahead and put the or in the middle. And I know it's going to have x with something and x with something. So I'm going from left to right. That first number is a negative 1. So I'm going to go ahead and put that in there. And then the next number that is has a dot next to it is a 2. So for the negative 1, I'm shading everything that's smaller than negative 1. So I would have to say x is less than negative 1 because those are the values that make it true. And then because it's a solid dot, I'm going to say equal to. Now for the next one, I'm shading everything greater than 2. So it's x is greater than 2. And that would be it because it is not an equal to. And that's the answer. Pretty simple. This next one is going to be an and inequality because it's going towards each other. So I know that and inequalities have an x in the middle. I also know that the signs are always going the same way like this. And then I'm going to fill in my numbers, and then after we'll kind of see if it makes sense. So I know it's between 1 and 6. So let's see if this makes sense. Is x greater than 1? Yes. And it's an open circle, so that sign works. Is x less than 6? Yes. However, I need to also make it equal to. All right. Last two problems are your turn. So again, go ahead and pause it, and then I will go over it. So for this first one, it is an and inequality because it's between two numbers. So I start off by putting my x. I know my inequality signs always go to the right. And I'm going to go ahead and put my numbers, which are negative 13 and negative 11. Now let's see if this makes sense. Is x greater than negative 13? Yes, but it's also equal to because of the closed circle. Is x less than negative 11? Yes, but it's also equal to. This one is an or inequality. It looks like oars, right? When you are rowing a boat. So for this one, I know I have x and x. I know it's dealing with 6 and 9 because those are the numbers with dots on them. So it's shading everything less than 6. So I'm going to use the less than symbol. And I don't need a line because it's not equal to, since it's an open circle. And then on this side, it's shading everything greater than 9. And I would need a line underneath because it is equal to 9. So that is everything for Unit 1 officially.